Hey everyone, this is Bradley Bush with another algebra video for you. Today we're talking about quadratic equations. It's a big topic in algebra. This is one of the big ones. Our to-do list, first of all, we'll talk about the definition of a quadratic equation. Then we'll talk about why we solve quadratic equations, why you should be interested. And then we'll give you techniques for solving quadratic equations, just a list of techniques and discussing them briefly so you know, if you have one, what your options are as far as solving. And then hopefully we'll provide some big picture so you understand when you're solving it what you're really doing. I'll also put the timestamps for these different parts in the video description, so if you want to skip ahead, you're more than welcome to. All right, let's start. Definition of a quadratic equation. So a quadratic equation is just an equation with x as a variable, or it could be something else, but a quadratic equation oftentimes in algebra will have x, and it can be written in this general form, ax squared plus bx plus c, where the a, the b, and the c are real numbers, and the first one, a, can't be equal to 0, or this first term is gone, the ax squared is gone, and you no longer have a quadratic, you have a line. So they are also called second-degree polynomials, and they're also called parabolas. Solving quadratic equations. Why do we solve quadratic equations? Good question. And surprisingly, there are many real-world problems whose solutions involve solving quadratic equations. As I, over the years, have looked at this and done problems, worked with problems in the real world, it's actually really surprising how many real world problems can be simplified down to or involve some way solving a quadratic equation. I think you'd be shocked. Some examples are finding max and mins, object trajectory, things going through space, finding the maximum size or the minimum size of an object. Say you're producing something and you want to find the minimum amount of aluminum for a pop can, and you want to make sure that it still holds a certain amount of liquid. That's an example, perfect example of something that would involve solving a quadratic equation. You can often use quadratic equations, or they're involved in solving problems that discuss where two things cross, like, for example, the average total cost and the marginal cost in econ. You also will see quadratic equations in problems involving where things start and stop, like population dynamics. If you're trying to find the optimum amount of movement through a system of stoplights, or you want to find the optimum number of different pieces of candy at a concession stand, or you're looking at population growth, or there's so many applications. There are many more that I haven't even talked about, but we solve quadratic equations because there are just many applications for it. What techniques do we use for solving quadratic equations? Well, there are quite a few of them. Here is a list of the 5 most common techniques used in an algebra class. The first one would be factoring. The second one would be completing the square. We also can use the quadratic formula, which is a shortcut to completing the square. So 2 and 3 are really the same thing. 3 is just faster than 2 is. You could also use graphing or some type of technology, like your graphing calculator or Desmos. Excuse me. And then you can also use the square root property if the situation you're dealing with is missing the middle term, the term that just has the x. So I actually have videos of all of these on my playlist, Algebra playlist. If you want to check all of them out, you're welcome to. Please do. All right, big picture. Finding zeros. That's really all we're doing here. So you might view solving a quadratic equation as purely an algebraic exercise, but the big picture is all we're doing is finding these x-intercepts. When you solve a quadratic equation, your answer is an x-intercept, and a zero is a different name for an x-intercept. So all we're doing is finding where the curve crosses the x-axis. If there's no solution, then that means your curve did not touch the x-axis, as you see here on the right-hand side. So big picture, solving quadratic equations, all you're doing is finding x-intercepts. That's it. Hopefully this video was helpful. It gave you kind of an overview of quadratic equations, what they are, why we solve them, what's going on when we're solving them, and some techniques that you can use to solve them. If you want more information, please check out my playlist, and I have plenty of videos on all the different techniques for solving quadratic equations. If this was helpful, please like the video and subscribe to the channel, and have a good day.